All right, that's really exciting. Nice to see you, everyone. And let's dive into this very interesting topic, MVVM at scale. I was recently reading a blog post that started like this. MVVM has been a trendy topic lately. And I can't agree more with that. I mean, during the past year, I kept hearing how it became one of the most used iOS architectures. If you feel late to the show because you don't know what MVVM is, or you never use it, I have to tell you a secret. We're all late. Because it turns out that this blog post was written by a .NET developer in 2009. I knew about the pattern for a couple of years now, and I use it here and there. But it never changed the way I design applications that much. I didn't feel that strongly about it. So I was really curious to know why the iOS community loves it so much and how it applies it. I started reading about it, watched some talks. I was a little bit confused at some point. To be honest, I had more questions than answers at some point. But that's fine, because those questions and that small research, it led to a lot of interesting discussions with colleagues. And I guess that's why I'm here today, to share with you some of the thoughts that I have and hopefully inspire you to think about designing applications from a different perspective. Let's start with a quick intro. MVVM defines 3 roles an object can play. It can be either a view model, or a model. And I intentionally put the view controllers on that diagram because, as with other universal patterns, sometimes it's not clear where certain iOS objects belong. But the key thing here is the view model. It keeps the view state and it exposes some mechanism for providing updates. That can be achieved through using key value observing, property observers, exposing RX observables, whatever you choose, like closures. And it doesn't really matter what you use. I mean, some techniques make it easier to do it, like reactive programming, but it's not really a requirement that MVVM sets. So why would you want to know about this pattern? For me, when I read talks and when I watch talks and when I read blog posts, the most interesting thing is the motivation that the author has to share his or her thoughts. And when it comes to MVVM, there is a quite stable pattern I see. It's almost always about view controllers in MVC doing too many things and thus being not testable, and how with MVVM you can address those 2 problems. And that's really good. I really like it, because I'm personally a big fan of making things more simple and testable. So yeah, let's take a look at some of the commonly used examples that you've probably seen around. And to illustrate them, I will use one view controller that shows a list of the places where a user checked in, like the places he visited for a certain period of time. And for this first example, we have a label that describes this time period. And that label can show different text based on the dates. So if both dates are set, we have one text, and then we have different text if only start date or end date is set. And that's quite a lot of logic to keep in the view controller. So some examples suggest that we can move this type of logic to a view model instead. And that view model will expose only the final string, and we're done. We can easily test this by not even instantiating the view. Great. This is another example that I want to show. Let's say that the user has the ability to change that time period in the same view controller using some date pickers. And every time a date changes, there are certain validations that need to be performed. I added comments here because the code is very long and it won't fit on the slide, but basically validating the time period, updating the text fields, updating the maximum dates for the date pickers. And again, we can move this code to a separate object that we only notify about the date change and then let this object perform all of those validations. So moving the business logic into this separate object. Finally, there is another type of logic that sometimes creeps into the view controller. And some examples suggest that we can move that also to a view model, talking about networking and parsing. Instead of the view controller knowing how to get its data and how to parse that data in order to show it, we can again move it to a separate object and just observe the changes in that object and reload the UI. Sorry. Oops. And if we follow those three examples, we'll end up with very light view controller that can be tested even without interacting with UIKit. But there's another thing though. If we moved all of those three things to one single object, it won't be very light. I mean, hiding complexity is not necessary, like it's not removing it overall. It's definitely good at a higher level, but working with a fat view model could be as fun as working with a big view controller. And when I see code like this, I ask myself, why? Is that how MVC really makes us write code? I don't know. I think that the fact that we had that logic in the view controller at the first place is not really MVC requirement. I think that this tweet sums it up really, really well. It's basically about a blog post for refactoring a big view controller that does a lot of things like navigation, data formatting, networking, all the things that we already saw. And the thing is that when you start with something like this, any solution that you present will look attractive, right? Because it will be definitely better than in the beginning. And these are some quotes from other examples that are doing really, really good promoting too. You can actually replace the MVVM with a generic pattern. And now you can cover most of the topics about designing applications. And some examples are so catchy, so overselling, that you can easily get into this mindset that you should be doing it, like you should be using it for everything. We all know that feeling. I mean, I was doing programming wrong, I have to start using this today. But that's not the way I think design solutions should be promoted. I think that we should focus on the root causes of the problems and not trying to affect only their symptoms. And by doing this, I mean, this is how I think we write good software, by understanding the concepts, making informed decisions, and not through encouraging something that I call community pressure-driven development. Preaching about MVVM when trying to learn something different, where MVVM is not necessary, doesn't really help. Some examples are good, but they should be focused. It should be clear what the example is showing. Taking some design shortcuts when you present a new API, like putting everything in the view controller, maybe it's fine. I mean, that's the goal of your demo, to show the new API and not explain how to use MVVM. You might be already thinking, if I actually use MVVM. Yes, I do. I want to show you a small application that I started writing for myself recently. And I'm doing this for fun, so I try to keep it tidy and familiar. I'm trying to use concepts that I used in my work. So yeah, it will be a static demo. Everything is on slides. So it should be fine. I hope so. The app is called Trip Check-ins, and it has views, models, view models, all of that. but that's not actually how my project structure looks. It looks more like this, and I don't have to tell you that I use Foursquare to get the check-ins. I don't have to tell you that I introduce like trips, adding and previewing them, because my project structure already does this. And I think that's way more important than having your project structure implying some design pattern usage. I say implying because putting something in the view folder doesn't really mean that it will not contain business logic. Or naming something a view model doesn't guarantee that it won't have UI code. So yeah, I think that when you're building an application, the design patterns that you use may change, but the intent of the code most of the times will stay the same. So try to make it clear for the people what's the intent of the app, and don't guess that they will know certain concepts. You actually saw some of the code for my app already during the examples. And it has this screen for adding a trip where I have the date pickers for selecting a time period. And there are some rules, like this one is resetting the start date when you choose earlier end date. And there is another business rule, like restricting the start date when end date is set. And there are some other rules as well. I decided to use a view model for this view for a couple of reasons, but this is how the view model looks like. So the reasons are that I didn't want to keep all of those rules in my head, so I wanted to document them in tests. And that's really easy with MVVM, so I thought, why not? And then when a date changes, the whole view basically needs to update. So I thought, yeah, maybe observing a view model seems like a logical solution. And last but not least, I wanted to change the native date pickers at some point to create my custom views when I have time. And I think that using the same interface can work with both UIs. So that's why I decided to use MVVM for this view. And it was really easy to use it. I mean, I captured all of the rules in tests without even creating the view. And the view controller also was really, really tidy. The code here is small, but basically the view controller fits on one screen. It does initialization, it adds the date filter creation view, and just does layout and captures the actions. And that's it. That's the whole view controller. But I would actually have similar logic if I was using MVC in my view controller. I'm actually cheating a little bit here because the nested view that I have is using MVVM, but the outer view doesn't know anything about the view model. So I would say that it's super similar to MVC. Let's take a look at another example that has more logic in the view controller. It's this screen that shows the latest check-ins the user has, and it has a dynamic title, it has loading state, error state, has more things. So let's see how this is done. The check-in item is how I represent the information that I get from Foursquare, and it's a simple struct. And then this is the way I present it to the user. So this is the view model that does date formatting. It constructs the location string, and it can have different logic, basically. But it's, again, simple immutable struct. And then I have this other view model class that is for the whole view that you saw on the screenshot. It has information about the title, it has information about the state, about the current view preference. It's basically a view model that is for the outer view that keeps reference to the nested view models. So we have nesting here. And I think that we should extract view model logic the same way we extract subviews that can be reused together into their own classes. In that way, we not only can reuse the view models, but we can also change the way they behave without thinking about the whole system and touching a lot of code. So everything so far was immutable structs, and someone needs to keep track of the state of the current view model. So in my case, this is another object. It knows the business rules and it sends updates. And it's also part of the view model layer in my application, although I didn't follow the same naming convention because I just think it makes more sense like this. But the important thing about this object is that it knows how to get the check-ins, but it doesn't really perform networking and parsing. I think this is part of the model layer, and the view model should know how to interact with the model layer, but they should not contain that type of logic. And then my view controller had only logic for keeping in sync with this view model. So I injected the view model. If you saw here, this check-in list view controller gets injected in the view controller. And that's basically my own preference. I like to keep the view models injected or created by other view models because this makes it easier to reuse even the view controllers. And in fact, in this sample application that I'm showing to you, I have this. I'm using the check-in view controller for two cases, for showing a trip and for showing a feed with all check-ins. So that's good, and we can test it. When you use similar approach, you have to think about two things. You have to consider them. One is if you have view models that may change super quickly, you may not want to reload the whole view every time. For example, if you have some logic that is location-based or playback-based, you may want to have some diffing logic or send more granular updates. And the other thing is if you're using a lot value types, just remember that when they are passed around, they're copied. So just be mindful about memory usage. And one thing that I didn't mention so far was how the navigation in this application happens. I left it for the last because it's not really MVVM related. Here in this app, I use a coordinator, but in my previous projects, I use routing by identifiers, by URLs. Doesn't really matter. I think wherever you choose, just try to make the flow logic easy to follow. Yeah. So I guess what I'm trying to say here is that I'm trying to be pragmatic when I apply MVVM, and that I combine it with other design patterns too. And I like to use separate objects that I consider part of this view model layer, because I think about design patterns as the components in the design patterns, they specify layers of objects, not a single object that knows everything. When I compare this to MVC, I think that it's not that different. I actually can't relate much to the motivation that I shared with you in the beginning. I would say something controversial, but I don't think that MVC is that bad. The best thing that MVVM does is that it forces you to create this additional object, because it doesn't feel good to call the view controller a view model, right? But sometimes it might be not necessary and just force you to write this additional redundant code. And that's why programming is so challenging, because at the end of the day, when it comes to technical solutions, complexity is the thing that matters the most. I really like this quote, and it continues like this. Once you understand that, oh, okay, I practiced this. Once you understand that all other goals in software are secondary to managing complexity, many design decisions become straightforward. And I think I did a mistake, but forgive me. Yeah. So I think that reducing the size of the pieces of the software that you keep in your head is actually leading to this testability. It makes testing easier, and it's just a side effect. And don't forget that when applying design patterns, they won't fix all of your problems. Just think about making things simple and keep in mind the design principles. Because you can still have a very big and complex view model that does a lot of things and has duplicated logic in MVVM. And you can have this tidy view controller that delegates tasks to other objects that have single responsibility with MVC. Doesn't really matter what design pattern you use. I think that's what's important when it comes to scale. If you follow these principles that were around for years, you'll be able to break a big system into smaller systems and focus on familiar problems, on smaller problems. So I think the way of doing good promoting is through giving more real-world examples and through focusing on the root causes of the problems and presenting some potential solutions, but helping people to learn and to make informed decisions. Thank you.